I want to take the derivative with respect to x of cosine squared x plus cosine squared y equals cosine of 2x plus 2y. Now the derivative of cosine squared, I'm going to use the chain rule. So bringing down the power, and then I need to multiply by the derivative of the inside, which is negative sign. For cosine squared, I'm going to do the same thing, except when I multiply by the derivative of the inside, I not only get negative sine y, I need to multiply by the derivative of y, which is dy over dx. Okay, so think of this as applying the chain rule twice. Okay, so first, the chain rule was the inside function, which was cosine of y, but then you also have y as a second chain rule. So you take the derivative of y, which is dy over dx. Okay, that's going to equal the derivative of cosine, which is the outside function. Inside is the same, and then we're going to multiply by the derivative of the inside. Okay, so now I'm going to have negative 2 cosine x sine x minus 2 cosine y sine y dy over dx. Okay, for this one, I'm going to pull out a 2 in front. Okay. So that's going to be negative 2 sine 2x plus 2y, and then multiply by 1 plus dy over dx. Okay, so I'm going to continue here. I'm going to FOIL out, or distribute the negative 2 sine 2x plus 2y. So I'm going to distribute it to both terms. Okay, and now I want to get the dy over dx is on one side. So I'm going to switch these two. So they're going to replace each other. So I'm going to have 2 sine 2x plus 2y minus 2 cosine y sine y dy dx. And that's going to be negative 2 sine 2x plus 2y plus 2 cosine x sine x. Okay, next step, they all have a factor of 2 in front, so that cancels. And I forgot the dy over dx here from this guy. Okay, so let's pull that out. So I have a dy over dx. Okay, and then what's left is sine 2x plus 2y minus cosine y sine y. That's equal to negative sine 2x plus 2y plus cosine x sine x. Okay, the last step here is to divide by what's in the bracket there. And at this step, it looks almost identical, the numerator and denominator, except for the second term, and the top depends on x, and the bottom depends on y. So, for these guys. Since that's the case, we cannot do any cancellation. So we're going to leave it as is. Okay, the next one involves a square root. So I have x equals 3 plus the square root of x squared plus y squared. In this one, it's good to rewrite the square root as whatever to the 1/2 power. Okay, because that way it's very clear how to use the chain rule. Okay, let's take the derivative now. the derivative of x is 1, the derivative of 3 is 0, and when I take the derivative of the square root, I'm going to bring down the power, keep the inside the same, subtract 1 in the exponent, and now I'm going to take the derivative of the inside. So the derivative of x squared is 2x, the derivative of y squared is 2y times dy over dx. And now I have two different functions multiplying each other. Okay. So I'm going to move the left function to the left here. So instead of having 1/2, I'm going to multiply by 2 on both sides. So that's going to cancel. And the square root is really in the denominator, right? So that's really like 1 over the square root. So I'm going to multiply that over. So that's going to turn out to be 2 times square root of x squared plus y squared. And I can factor out these 2's. So it'll be 2 times the quantity x plus y dy over dx. Okay, the 2's are going to cancel. And I'm going to subtract the y, or sorry, subtract the x here. So I have y left times dy over dx. And then finally, I'm going to divide by y. So that's my derivative. Let's look at x minus y cubed over y plus x squared equals x plus 2. Okay, this one we have a couple of options. We can use a quotient rule, or we can multiply it to the right and avoid it. Here I'm just going to multiply it to the right and get it over with. So I'm going to have y plus x squared times x plus 2. And I'm going to avoid the product rule, so I'm going to FOIL it out. I have xy plus 2y plus x cubed plus 2x squared. And at this point, the derivative should be much, much easier to take. Okay, so there's nothing, with the exception of xy, none of those should be that much work. So let's go step by step. The derivative of x is 1. The derivative of y cubed is 3y squared dy over dx. And the derivative of xy, I have to use the product rule. So I'm going to take the derivative of x times y plus the derivative of y times x. And then 2y would just be 2 dy over dx plus 3x squared plus 4x. I have 2 dy over dx's on the right, so it makes sense to put everything over there. So that means y, 3x squared, and 4x will all go to the left here. And negative 3y squared dy over dx is going to the right. Okay, so that's 1 minus y minus 3x squared minus 4x is equal to dy over dx times x plus 2 dy over dx plus 3y squared dy over dx. Okay, next step I'm going to leave the left side alone, and then I'm going to factor out the dy over dx on the right to get x plus 2 plus 3y squared. And the last step, I'm going to divide everything by the whatever's in the parentheses. And that is my derivative. So this one wasn't that bad to find the derivative. Let's do one more. I have y over x cubed plus x times y cubed is equal to x squared times y squared, or y to the fourth. Okay, this one, I have denominators, and I'm not a big fan of that. So we're going to be clever, and we're going to multiply both sides by x cubed times y cubed. So when we multiply x cubed by y cubed by the first term, the x cubes are going to cancel, and I'm going to get y times y cubed. And if I multiply x cubed y cubed by x over y cubed, the y cubes are going to cancel. So I'm going to be left with x to the fourth. And then x squared times x cubed is x to the fifth. Y to the fourth times y cubed is y to the seventh. And here, this looks much nicer. Okay, let's take the derivative of y to the fourth is 4y cubed dy over dx. X to the fourth is 4x cubed. And on the right, we have to use the product rule. So that'd be derivative of x to the fifth times y to the seventh, plus the derivative of y to the seventh is 7y to the sixth times dy over dx. And we're going to multiply that by x to the fifth. I'm going to move that term on the left. So I have 4y cubed dy over dx minus, so we have 7y to the sixth times x to the fifth. So I have that, dy over dx. Okay, and then we're going to move the 4x cubed over. So we have 5x to the fourth, y to the seventh, minus 4x cubed. We're going to factor out a dy over dx. And that's going to give us 4y cubed minus 7y to the sixth times x to the fifth. And that's going to equal whatever is on the right. Okay. And then finally, we're just going to divide what's in the parentheses. And that's my derivative.